The current status of RavenDB is like this. Do you see PowerShell now?
I do.
Okay, so this is RavenDB actually building a new build, and assuming that everything goes right, then during this conversation we're actually going to have a new build show up. That should be build 547. Yes. And I started RavenDB about close to 3 years ago now, and mostly because I didn't really have a choice. Did you ever have that feeling that there was something on the top of your tongue and but you couldn't remember what it was?
Yes.
So that was how it was for me. But it went on for over a year, in which I was keep trying to do more and more. Just kept trying, okay, I will figure it out, I will do something with that, stuff like that. I basically got involved in the NoSQL movement by starting to read the code base of CouchDB and other databases like that. The problem is that in most cases, what do you know about NoSQL databases in the first place? Does anyone know? Anyone want to take that?
Well, I can jump in if you want. I would say, from my experience, a NoSQL is, generally speaking, a document database. But it also means, what, not only SQL?
Yeah. So why would we ever want to use a NoSQL database? I mean, we have SQL databases. They've been good enough for 20 years, 30 years.
I would maybe ease of development, especially from an object-oriented perspective.
That's one of them. A major reason why people started getting into NoSQL solution is just the fact that we run out of the ability of SQL databases to provide us with reasonable performance and scaling option. So the common option in a relational database to scale a system is to get a better hardware. Eventually you run out of better hardware, and probably much sooner than that you run out of budget. So we had to figure out better ways of scaling our systems, of getting the appropriate performance out of the things that we are doing. And the thing that people decided to say, okay, let's figure out what is wrong. And what turned out to be wrong is the exact strengths of the relational model. So you had people that says that, oh, I really like the ability to have relation between data. And you have people that says, oh, I really like to be able to define constraints and uniqueness and other stuff like that. The problem with all of those things is that they came with a horrendous amount of baggage. What do you mean by that? Let's consider, for example, something very trivial. I have a feature that basically says that I want a unique username in my application, right? How hard is that to do? It's fairly simple, right? You basically just put a unique constraint on the username column and you're done. Or maybe you need to do some error handling, but basically putting the unique constraint there is all you need to do. The problem becomes, what happens when you need to scale higher? Well, maybe now you have 2 databases, right? Maybe 3 databases just to handle the load. Your previous example of just add the unique constraint and you're done now no longer works. More than that, depending on how you set things up, it can actually be very, very hard to ensure that you don't have some sort of concurrency violation while you're trying to create a unique user. Because maybe, one request for user A and goes to database A, and the second request to database to create user A and goes to database B. And that is a perfectly legal thing to do, no matter how many unique constraints you're going to add. So that is a very important observation, because it means that the moment that you start working at more than a single database, then a lot of the benefits of relational database just goes away. For example, I might want to say that I'm going to normalize my data, so I only have to update it in one place. And that's very good thinking in general. But what happens when I'm working on multiple databases? Well, then loading the data for a single page means that I have to load the data from multiple databases. And that's okay if I'm working on 2 databases, maybe even on 3 databases. The performance hit will be noticeable, but I can still live with that. But what happens if I have 20? At that point, just the cost of traversing off those associations, remember, because we're using different databases, we can no longer use joins. So we have to grab the data from one server and then grab the data from the second server. And if we need to do a join, we have to do that join in memory. Right. So that's an entirely different problem that we don't even want to have. So what is the next step? What is the next problem that we have to deal with? And the next problem that we have to deal with is the notion of relations. Again, for the same reason, if I'm going to relate to some other object, it has better be in my database so I can join to that. If it's not in the same database, then again, all of the problems having to do the join by myself, having to hit multiple databases, and other stuff like that. And then we have another problem. Another problem is what happens when we are actually, it's not so much as a problem. It's a state of mind. We have always worked with relational databases. For as long as I've been alive, user relational database has been the recommended solution. And there's just one problem with that approach. There are disadvantages for using a relational database. Some of the things that make a relational database so good is also some of the things that make it so bad. For example, schemas. Schemas are wonderful features of relational databases. They allow to do tremendous amount of optimizations because it knows what sort of structure the data is going to be. But what is the downside of schemas?
Rigidity.
Okay, so, I need to add a new column. Suddenly it's become something very, very complicated. Did you ever work on a project where you had a separate DBA in all schema / store procedure changes had to go through him? And yeah.
Yeah, I have not personally, but yes, I've heard many horror stories about that. So,
yeah. So try to imagine that you need to do a. So I was giving a lecture in the army, and there is a certain pace to a lecture. Hi, my name is Oren. Now I'm going to tell a joke. And I started telling the standard set of jokes, and nothing. Like, what? You don't care about budgets? Oh yeah, you're in the army. You don't really care about things as budgets. And you don't worry about things like licenses because the army basically have a site license for the entire war. So, then I said something about DBAs and having to wait a week for the DBA. And everyone fell down laughing. I'm like, okay. I know it's a joke. It's supposed to be funny. It doesn't be that funny. And they told me that I must have an excellent DBA if I only had to wait for a single week. By the way, did you know that standard practice at a company that I was working for was to make all Boolean fields int? Why would you make a Boolean field int? Do you know? You dare to guess?
I would say because Boolean at its root is either a 1 or a 0.
Which requires only a single bit.
Right.
Which means that now you have extensibility, because if you need some new value, you have these 31 bits that you can use, and you don't have to talk to the DBA for that.
Right.
Okay, and then you have then you get into real horror stories about schemes and stuff like that. But even if you're not, you know what, let's leave aside the nasty process of updating the database. Let's just talk about standard deployment when you control everything. Think about going to production and having to modify the database schema. That is one of the scariest things that you can do, because now you're very, very deeply touching all of your data. It's very, very easy to do something that would, you know, drop table, delete data from table, all sorts of stuff like that that we really want to avoid.
Right.
Okay. Leaving aside the fact that schema management is such a painful topic. So that's one aspect of that. Another aspect of a relational database that is really, really annoying is what is the data format that I actually have with relational databases? I got tables and columns and rows. Okay, that's nice. I can put my name is Oren and my age and my date of birth is so and so and blah 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 blah. That's very nice. But what happens if I need to store data that doesn't fit into a single column? For example, what happens if I want to store the name of my dogs? I have two of them. It doesn't fit into a single column. So how am I going to handle that?
You create another table.
Yay! And then you get into the situation where, then you get into this situation. Second. Let's see how long it's going to take to load. Okay. Tell me when you see that.
Okay.
This is from 2007, if I remember correctly. I was working on a project. We had a very nice schema for that model. Unfortunately, loading the data efficiently was quite hard. Are you seeing anything?
Nothing yet.
Oh yeah, I know why. Because what I shared was
your PowerPoint, not your desktop.
Oh, okay. Now we should be able to see that.
Okay, it's coming through. There it is. You want to see how far you can shock Rob Connery.
Yeah. Okay. Me and Rob had a long discussion about efficiencies and how you're supposed to do stuff at the time. It doesn't really matter. But the most important piece of it is that this wasn't some idiot doing that. That was me writing the code. And it was very, very easy to get into that situation where a single page caused hundreds and thousands of queries. And in many cases, I'm spending most of my time with clients just look at your schema. Now, leave aside all of this Hibernate crap that I've been talking to you about for the last 3 days. Let's pull up SQL and show me how you can efficiently get the data that you need for this page. And in many cases, you literally cannot. Even for simple stuff. Look at this web page. Okay, when I was running that with subtext, loading a single page on my blog would result in 11 queries, 11 store procedure calls, and it had to touch 19 tables. That's 19.
Wow.
And that is to load a single blog post. And again, I consider that to be an insane amount of operation that you have to make over every single operation of the blog. And I mean, it's a blog. It doesn't really do something very, very interesting.
Mm-hmm.
So the reason for that isn't that the developer for Subtext are stupid. It's just that by using the relational model, they were forced to split every association into different tables, and then you have to join all of the information or query for all of the information at retime. Which brings me to another topic. it makes absolute sense to optimize for fast writes, right?
Correct.
So, because I'm reading so much less than I'm writing.
Wait, you're reading less than you're writing?
Of course, because I'm optimizing for writing. I'm optimized for writing very, very fast. I'm not optimized for reading. Because in most systems, there is an order of magnitude more writes than there are reads. Is that correct?
I would disagree with that.
Okay, so can you explain to me why what is the reason for the relational database decision to make writes very fast, but make reads more expensive?
You got me.
Because think about what it's actually doing. The relational database basically says, okay, you split the data, and when you need to update or insert the data, you only have to touch it in this place. But when you want to read this data back, you have to join it from all over the place.
Right, right.
Okay, so that's a big problem. And when people stopped when people had to stop using relational databases because they ran out of room on their machines, everyone sat down and started thinking, okay, we cannot use a relational database, so what are we going to do? And there were a couple of options that were on the table. One option was, okay, let's create something that can run on a relational database, but on the web, on a web scale scenario. And that something is usually called a big column database. If you ever heard about Google's Big Table or Cassandra, and there's another one, HBase, I think it's called, or those are all databases that would look on the surface to be very similar to relational databases that have been stripped out of everything that make it hard to run on massive amount of machines. But those things tend to be very, very specific for scaling scenarios. Mm-hmm. Another situation, another thing that rose out of the need to create to have a solution for running on scalable systems is the notion of document database. Now, document databases basically allow me to treat anything as a document. For example, what I'm going to show you now is, yes. Now, I'm going to show you the backend database for my blog. Okay, do you see that?
I do.
Okay.
Is that the new user interface for?
That is the new user interface. I should warn you that this is actually somewhat old. 1 second. Because this is from 3 days ago, and we had a few builds afterward.
All right.
Okay. And okay. So let's look at things. First of all, just minimize this a bit. Okay. So let's see how things are actually looking. Okay. You can see that we don't have just those are documents. You can see that some documents, that any document looks different. We have comments, post, system, doesn't really matter.
Okay.
And we don't have any structure to them. In this case, the commenter, you can see that this is just standard name and value. In this case, if we look at post comments, you can see that we have complex object. In fact, what we see here is an array.
Okay.
Okay.
Array of complex objects.
Mm-hmm. And just think how hard it would be in a relational system to represent something like that. You have to use multiple tables and choice and things like that.
Right.
With RavenDB, it's as easy as just storing the data. Now, the next question that we have to ask ourselves, okay, so I can take any JSON object, and let's look at another one of those, another complex JSON object, and store that inside the RavenDB. But that is only part of the job. So the next step that we actually have to do is to get it out. And there are two ways that we can get that out. You can get that out of RavenDB. One of them is by doing something like this. I know what the ID is. Maybe I got it on. Yeah, I know. As I said, this is an old build now, and it doesn't support. And it has some bugs in it.
Okay. No problem.
So, the 547 is currently building. So by the time that we finish this talk, we should have a fix for that. So now you can see, if I have this value, I can directly get it from the database. It's very, very easy to do. But what happens if I want to do queries? And this is where things are starting to get very, very interesting. Okay, so for example, I want to query. Why are you here? I don't need you. Never mind. Let's say that I want to query all of the users. Okay. So here are a list of the users. Okay. And I want to query them by their email. The way we have fully deleted, which I really, really like.
That's nice.
Yeah. So it actually can go and look at the values that you have in the database to give you both the things that you can do here, both the field names and the field values. Okay. So what you've seen here is us asking, okay, give me all of the users whose email is Ayende. So we just perform a query. But remember that this is basically just, as far as RavenDB is concerned, this is just random text. We don't know how to parse that. So how are we going to handle this? This is where indexes comes into play. And this is an index. Does this look familiar to you?
Yes, it does. It looks slightly like link.
Mm-hmm. Not slightly, exactly. Because this is what we are actually doing. We basically, it's something that just said, you know what? SQL Server has SQL. I also want a query language. But you know what? Implementing a query language is actually quite hard, so I didn't want to do that. And I also didn't want to document that. So instead, I installed the language integrated query that is already in C#. So tell me what this index is doing.
It's looking for a doc in all in the user's documents, and it's selecting, it's projecting into a new object where the email doc.publish at, and the email is doc.email. So
it's projecting out the email and the publish date for the users, which I don't really know what publish it means for users, but okay. So why is that important? It's important for one very interesting reason, because this is actually the index definition. What we're actually asking RavenDB to do here, go over all of the user documents, extract the email from the user document and put it in the index. That is why I'm able to do things like this. Let's look at something slightly more interesting. Why do we have it as WC? Okay. Okay, so let's look at slightly more interesting example. We don't care for that. So here we have, this is for the Daily Build website. Okay, this is how the data looks like. And now we have things like, I want to look at all of the categories of all of the downloads. Whoa. Yeah, as I said, that's a bug. Okay, so let's look at all of the categories for all of the downloads. I need to refresh that. 1 second. Good. All of the downloads for RavenDB. Okay, and now you can see that here all of the downloads for RavenDB.
All right.
I can sort that and blah blah blah. No one really cares. Let's talk about something much more interesting. Okay. This is slightly more complex example, but let's look at what's going on. What is happening in the map?
Trying to get the number of downloads per month per category.
So for each category that we have, I'm going to project out the category, the month, and some count. Okay, number of categories. I probably should mention what number of categories is. Number of downloads. So this is what it looks like. Number of downloads per month. So this will publish this month, and this month it has 100 downloads.
Okay.
Another one. This was published. Okay, and this has tons of downloads this month. So this is how it looks like, and this is the output. So we're doing a select many out of number of downloads per month, and we're taking the month and the count for every category. Okay, so far?
Okay.
What is happening in the reduce?
Well, you're grouping the results by month, and then projecting that into a select. So you're selecting, you're getting the count.
So I'm doing an aggregation over the entire data set.
Mm-hmm.
Let's see what happened. I want to see all of the results for Raven and month. Second. So here are the numbers. Okay. So RavenDB was downloaded 1,700 times this month. NHPOF 5266. Now, try to think about this for a second. What would be the cost of doing something like that in a relational database?
Quite a bit, quite heavy.
Okay. First of all, I would need to do a lot of work in my model just to be able to get away with doing this, because I don't get to be able to do that in any way. And if I was able to do that and I wanted to do those sort of queries, well, I could do that, but that would be a very expensive query. With RavenDB, I don't know if you noticed, but here's the number for last month. You see how far? Oh, that's a nice number. Don't spend as much time as I probably should looking at those numbers. So you can see that the numbers are generated almost instantaneously.
Right.
So this is a remote machine that I'm using. Oh, can you see my mouse?
I sure can.
Okay, so this is a remote machine that I'm using. So most of the time it's basically just going grabbing the data. And if I remove that, you can see that it gave me the values for everything. And that is actually in total contradiction to how I actually want to go about doing most of those operations in a relational database. I want to limit the operation as much as possible because doing this calculation is so expensive.
Right.
The difference with RavenDB is that because we define those two things together, now we're able to do something very interesting. We're able to say, you know what, the database knows about this. It's going to optimize those operations for us. So what is actually happening is, on the background, this is getting calculated and computed. And whenever we make a query, we aren't actually making a query that requires any computation. What actually happened is that we already have this ready for us. And now we only have to check, oh, the month is this, the category is that, and so on and so forth. Right. Nothing beyond that. Okay? Mm-hmm. And what else can I show that is cool? What is in this test database? So now we have other stuff that we can do. For example, we can do albums by count sold. So this is an album you can see that was sold 2 times. So we're able to really do interesting things. We're able to create those sort of things very easily. We're able to query that normally, so we're able to get all of the data that we want. And we don't have to worry about how things are actually going to work.
Okay.
Because we can just shove things in and it works. By the way, you can see that we have here a reference to a journal. Go here and look at the actual journal. But this is a weak reference. What do I mean by weak reference? I can put Orlando here, and that would still work. That would still work, and you can see that could not find journals Orlando.
Right.
Okay? So that's what I meant by having a weak reference. Because nothing promised me that this would be a real thing. We don't have an artist in the database. Artist is actually a computed thing. So that means that I don't have to worry about relational integrity. And if I want to run over multiple databases at the same time, it's very, very easy for me to do so. Because journals may sit in a different database altogether. Again, I'm not limited to what the relation model says that I have to. I'm still able to make queries, including aggregation, queries that would be enormously expensive in a relation system very, very easily. And just the freedom of being able to model data anywhere I want is fantastic.
Right.
Okay.
Yeah, we have a question actually, Ayende.
Awesome.
Question from Greg, and Greg asks, let me expand it here. Is it possible or recommended to cascade or chain indexes together? For example, begin with coarse-grained indexes, i.e. indexes containing many result items, and then create fine-grained indexes where the indexes will contain a few result items that use more coarse-grained indexes as their starting point?
No. Indexes always work on top of the actual document model. There is a very good reason why you want to do that, and the major reason is that if you don't do that, very bad things will happen. So we always use indexes as they are, and we always use indexes as they are. It's usually better to have fewer and bigger indexes, so indexes that cover more data than smaller indexes that cover just specific information. That is because most of the cost in indexes is actually doing indexes itself. So if you have two indexes that run over the same data set, just one of them is outputting the email, one of them outputting the publish it, then it's more expensive than having a single index that output both of them together.
Right, and then do a query on that index based on the
And I think we have a dev here that would like to speak.
That's correct. He says, are dynamic indexes sufficient enough?
Good. 1 second. Let me see if I can. No, I don't think that he has what's it called?
A mute or a speaker?
Yeah, a speaker. Yeah. So anyway, so are dynamic indexes sufficient enough? The question is sufficient for what? So we haven't actually shown that. But we have the ability to do dynamic queries. For example, I want to look at all of the albums, and I want to find the one. Let me see what the data looks like. I want to find all of the albums where the title is this. So dynamic query, title. Okay, yes, that's the bug. So you see that it found out something that has this value. Okay, but if we go here, now we're able to see that we have this temporal index that was created for us dynamically. Okay, basically go over all of the albums and project the title into the index.
So basically that index was not predefined in your database. That was something that you just did on the fly dynamically.
Exactly.
And it created this temporary one.
Exactly. Now let me show you something really interesting. Again, now we're looking at my blog. Now you can see that we have this thing that is a temporary index, and we have a lot of auto indexes. What are those auto indexes? Those are temporal indexes that have been used often enough to become permanent.
Often enough where?
By the application.
By the application inside your code specifically.
Inside, so we have this application. We have new tab. So we have this application, my blog.
Mm-hmm.
And my blog is using this database. And it's making all sorts of queries. And those queries eventually, most of them started as dynamic queries. They were temp indexes. And after a while, there was enough queries to make this into an actual permanent index. So it was promoted from being a temp into an auto. This index, if there isn't enough activity over, I think, 10 or 20 minutes, that index will be deleted. All of its resources will be garbage collected.
Okay.
Okay, so that's the major distinction. Now, there are some things that you cannot do with a dynamic index. For example, if I want to look at the post statistics, then this is a MapReduce index. MapReduce index doesn't allow me to, I cannot really do MapReduce indexes through the, you see, this is a MapReduce index that counts all of the comments and all of the posts. Here is how it is defined. I cannot do that through dynamic index. That I have to define upfront.
Okay.
Most of the time when I'm defining indexes, there would be some sort of stuff like that. Things that I cannot define on the fly. This I don't like this one. Give me a second. Let's move that. And if my blog stopped working, now you know why.
Okay.
Let's see other stuff. Oh, here is another interesting one. This index is the backend for this feature. second. You see here, let's see. Here it is. You see that we have al.net 31, blog 107, books 116, and so on and so forth.
Oh, in the right column there? Under the
Right
tags?
one, the tags, yes.
Okay.
So this one is being served from here. Okay, again, you can see that we have different values. al.net 31, call of the week 40. Last time that I posted call of the week was in 2008.
Okay.
Again, looking at the result, this is how this is done.
Right.
Okay, try to do something like that in a relational database, it will become very, very expensive.
Right.
Okay, so those are the sort of things that RavenDB allows you to do very, very easily. And more questions, please.
Well, I actually have a question of my own. Something that when I talk about this in circles, in dev circles, the first reaction is relational integrity, and my response, or I talk about RavenDB, and they say, well, what about relational integrity? And then my response is that that is counterintuitive to what RavenDB or document databases is all about. Could you talk about the mindset? For me, it became a mindset that I had to change in order to understand what document databases was, how to architect a document database.
That's a major distinction between how you do something in a relational database, how you do something in RavenDB. For example, let's think about the most simple example in the world, and that's the order entity. When we define an order, we have the actual, we have order, we have a customer, we have a shipping address, we have home address, we have discounts, we have payments, we have order lines, and we're still at a very, very simple model, right?
Right.
So reorder system contains much more information about that. Maybe you have helpless information about an order, all sorts of stuff like that. And when you start thinking about, okay, what of this is actually an entity in its own right that deserves its own life cycle? And what of this is actually something that belongs truly as part of the order itself? Is something that doesn't have any right to exist outside of the order.
Okay.
And when you look at something like that, you realize that, you know what? Out of all of the things that I just mentioned, maybe customer has independent existence. Maybe the addresses as well. Probably not. But it actually makes a lot more sense to just put everything inside the order as a single entity, as a single document. And you have tried to imagine doing a page to show you your order status. And you have to get all of this data from in RavenDB from a single document. It's a piece of cake. You have nothing to really think about. And in relational database, you have to work on so many tables, and you have to be very careful about how you do things in order to make things perform properly.
Right.
And let's talk about the other side of relational integrity. Okay, let's talk about the order's home address and billing address. So I don't know about you, but if I go to Amazon, I have about 8 different addresses that they ship to over the years. Now, people move, addresses change. So let's talk about the most trivial example of me wanting to handle addresses in a relational database. I'm going to put the home address ID and the billing address ID inside the order column, inside the order table as 2 columns. And it looks okay, except that what I've actually done right now is introduce a data corruption bug. How come making things normalized and good is now a data corruption bug? Because think about that. If I ship the order to my house and a month later I move, so I update my address, and then I want to go back and look at that order, what am I going to see there?
You're going to see your new address instead of the one that it was originally shipped to.
Exactly. So in many, many cases, we actually do not want to normalize the data because that data doesn't represent a link. It represents a point in time.
Right.
By the way, probably in the same sense, my name is also should not be changed over time. If I change my name, that doesn't mean that whoever that package was meant to should be changed, especially not retroactively.
Right.
So that is one common answer that I have for people who says, "Oh, I want to still have relations." The other answers for that is that okay, you have made a determination that this is really a link. This is not a point in time data. For example, it may be that you have a person object, and that person object has a current address property.
Right.
Or maybe current address is not so good because let's say that it has a partner property or spouse property.
Mm-hmm.
Okay. Now that other person that this property refers to is an independent item, right?
Right.
We cannot just, you're a person, so and you're married to that person, so you're now a single entity. You're
Right.
still two different, distinct entities in the system, but there is a link between the two of you. And how do you represent something like that in RavenDB? You represent that as a link. Just as we've seen before with the album and the genres. We don't need too much there. We just need to
represent it by its ID.
Yeah, and you're done. Now, what happens if someone deletes that information? If someone deletes the spouse while the other spouse is still there? Well, now you have data integrity problem. That is absolutely the case. The question here is, what is this? What is the actual problem that you have? And this is a problem that you're going to have anyway, the moment you step beyond the single node in the system. So, in many aspects, not doing that, not trying to enforce integrity on a single node, is actually something that we're being very careful about, because this allows you to prepare for when you're running on multiple nodes.
Okay.
And if you really want to have a relational integrity, we actually have an extension to RavenDB that adds that. So that's about as easy as you can make it work.
You have a component that adds that?
Yes.
Okay.
We don't recommend using them again because this makes things harder on you, but you can do that.
Okay. We actually have a couple more questions here.
Okay, wonderful.
Greg asked if can RavenDB store binary data, and is this a recommended use case? Many of our applications expect data to arrive as XML until such time that we can convert the application to understand JSON. Is it better to store the XML as a single value on RavenDB or convert the XML to from JSON for storage retrieval?
Yes. RavenDB can store binary data. It is not really recommended uses. We allow that. There is a whole set of API that is meant specifically for that purpose. It's called the attachment API. But if you store it in the binary data, you basically turn it into a file server. That's not its intended usage. It will be significantly better to store the data as JSON, because when the data is JSON, you store these documents, then you can work with that. We actually have an API that allows you to translate from and to JSON very, very easily on the client. So you can tell us, oh, here is an XML document. We will translate that into a JSON document, and then you can just save it into RavenDB very easily. I would say that this is a far better option rather than trying to store the data as binary.
And that would be the same goes for like storing, say, for example, JPEGs, which are not XML documents. So that would be, you would probably store that on a separate file system and then have a reference link to that file system?
That's one option. Another option, because this is now you're talking actual binary data, and those tends to be small, you can put them directly inside RavenDB's attachments.
Okay.
What this basically do is basically, we basically allow you to do that so you can do things like store the profile pictures and stuff like that. This isn't a core feature. What do I mean by this isn't a core feature? It's not something that RavenDB is really meant to do. It's just that if you want that and it's not really an important thing, then if you're not, you're not going to start storing files of tens and hundreds of megabytes in there, and you're not going to start doing crazy stuff with tons of files, then you can do it with some level of efficiency. But if you're actually going to store a lot of information, it's better to choose an actual file server rather than trying to use RavenDB for that.
Okay. Another question we have is from Ben. He says, I noticed sometimes speed related to a simple query results in a slow response. Is there a large overhead of HTTP that could cause this? He says, this query seems fairly simple. However, I've seen it take as long as 500 milliseconds to complete with about 40 entries. The documents themselves are fairly small. He says
he showed the API for doing that. And Ben, the reason that you're seeing that behavior is that what you have is a dynamic query. And the first time that you run this dynamic query, it has to create the index. If you will notice, the second time that you make this exact query, it's going to return in essentially 0 time. The reason for that, the first time that you make a query, we run the query optimizer over the query that you gave us, and then we make decisions about how to which index it has to go. And if we can't find an index that match the query that you gave us, then we are going to create one. Creating an index is expensive, but the second time that you make this query or a similar query, that index is already going to be there. It's now a temp index. We discussed this and we showed the example a few minutes ago. Now, if you make a lot of queries on this index, that index is going to be promoted into an auto index, which means that it's going to survive over the lifetime of the system. If you don't make enough queries to make this into an auto index, then that's going to be just a temporary index, and eventually it will go away when you don't have enough queries for that.
Ayende, is there a way in the client API that you could force the query that you just, a dynamic query to be a permanent query, like just a call that says make permanent or something like that?
Run it in a loop for 100 times.
Okay. Easy enough.
Yeah, or if you want, you can actually go and grab the data from set the configuration value, so you will have a lower threshold for how often will we, what is the number of queries over an index that requires to promote it into an auto index.
Okay. So you just change the setting on the server side to be maybe like 5 queries and it becomes the permanent index, and then
Yes.
Okay.
Yes.
Very nice.
Okay.
I thought there was another question, but it looks like it disappeared. So.
Yeah. Okay. Oh, here it is. Regarding schemas, can RavenDB do partial imports or exports? Meaning, if I have users collection, orders collection, I want to import all users. Always can it detect already? I don't understand the last part, but right now, so RavenDB has the ability to import and export natively. It's directly in the UI, but we don't do filtering. There isn't any reason why we don't do filtering. It's just fairly low on the priority scale. That's about it.
All right.
Yeah. And I think that will give people one last question.
All right. I have a question of my own.
Okay.
Is
You
there?
don't count.
Aha!
No, your question doesn't count. I mean. Okay, so you ask it. Yeah. In the meantime, guys, if you have any questions, please ask, and that will be last questions after yours. Yes.
Well, my question is, what about RavenDB as a service?
We have a project right now that is building that. We hope to go into private beta. Well, not this month, but in the next 2 weeks. And hopefully we'll have something for the new year.
Sounds great.
Mm-hmm.
All right. We have Greg has another question. He says, what strategy would you recommend for notifying clients that an item has been added to an index, and does it make sense to use SignalR in conjunction with RavenDB to accomplish pub sub functionality? Are there any use cases, examples where it makes sense to use SignalR in conjunction with RavenDB?
It really depends on what you want to do with that index update. We have a plugin mechanism that allows you to say, oh, that item has been added or removed from the index. It makes absolute sense to be able to do just what Greg has suggested, to use SignalR and Pub sub to do so. The way that you would do that, you basically write a plugin to RavenDB that would let you know when items have been added or removed from the index, and then you would use SignalR to basically publish it out.
Okay. Maybe explain what SignalR is.
Oh, SignalR is a really nice system that allows you to do a pub sub over the web. So you basically have a host. That host can have client connect to it, and you can basically push and pull notification from all of them. The easiest way of thinking about it is think about a chat room or chat application, where you can push a notification to a room, and everyone can see that notification.
Okay. Perfect.
I think this is it. Okay, guys, if you have any additional questions, please go to the mailing list. You can find it through the website, RavenDB.net, and then go to the support section and ask. We'll be very happy to answer that.
And you also have a Google Groups discussion feed as well.
Yes.
And you can find that, I'm assuming, I think you can find that on the RavenDB.net website. Is that correct?
Yes.
All right. So search for that. There's a lot of good back and forth information there, so that I've found personally. So with that, I appreciate your time, Ayende, and for giving us a breakdown on RavenDB. And again, like you said, like he said, if anybody has any additional questions, feel free to visit the RavenDB.net website and look for the Google Groups or some of the documentation that they have. There's a book. I know there's a book there. It's a living document book that they're writing. So definitely take a look at that. So thank you very much, Ayende.
You're absolutely welcome.
All right. With that, we will go ahead and close this meeting. And thanks, everyone, for attending.